Now, residential lighting circuits are generally not considered continuous loads. A continuous load, according to the National Electrical Code, or NEC, is defined as a load where the maximum current is expected to continue for 3 hours or more. In residential settings, lighting loads are typically intermittent. This means they are not expected to operate continuously for extended periods of time, like 3 hours or more. Now let's discuss dedicated lighting circuits. The NEC mandates that all lighting circuits in dwelling units be dedicated. A dedicated circuit exclusively supplies lighting loads, and no other types of loads. However, in practice, electricians sometimes wire lighting circuits with other types of loads such as receptacles. While this might save time and money, it does not align with NEC requirements. There are several reasons why dedicated lighting circuits are important in dwelling units. Firstly, dedicated circuits help to prevent overloading. When too many loads are connected to a single circuit, the circuit can overheat, creating a potential fire hazard. Secondly, dedicated circuits ensure proper protection by circuit breakers or fuses. If a lighting circuit is overloaded, the circuit breaker or fuse should trip, preventing damage to the circuit and the connected loads. This safeguards the electrical system and minimizes the risk of electrical fires. Wiring practices and the NEC. It is important to understand the implications of deviating from NEC guidelines. Combining lighting circuits with receptacle circuits may seem convenient, but it can compromise safety and code compliance. Overloaded circuits can lead to nuisance tripping of circuit breakers, potentially plunging areas into darkness. This can be particularly problematic for safety-critical lighting, such as stairwell or emergency exit lighting. Furthermore, mixing lighting and receptacle loads can make it difficult to determine the appropriate circuit breaker size. The NEC provides specific guidelines for calculating the load on lighting circuits, taking into account the type of lighting, the square footage of the area, and other factors. When receptacles are added to the circuit, it becomes more challenging to accurately calculate the total load and select the correct circuit breaker size. To ensure safe and compliant electrical installations, it is crucial to adhere to the NEC requirements for dedicated lighting circuits in dwelling units. This practice minimizes the risk of overloading, ensures proper circuit protection, and promotes overall electrical safety. Now let's delve deeper into the NEC requirements. The NEC provides comprehensive guidelines for electrical installations covering various aspects, including wiring methods, overcurrent protection, grounding, and equipment installation. It is essential for electricians, electrical contractors, and homeowners to familiarize themselves with the applicable NEC provisions to ensure safe and compliant electrical systems. NEC Article 210 covers branch circuits, which are the circuits that supply power to lighting, receptacles, and other loads. This article specifies the requirements for circuit sizing, overcurrent protection, and permissible loads. NEC Section 210.11 addresses branch circuits in dwelling units, outlining the minimum number of branch circuits required for lighting and receptacles. It also specifies the requirements for dedicated circuits for specific appliances, such as laundry equipment and kitchen appliances. NEC Section 210.21 provides guidance on the use of branch circuits for lighting and appliance loads, specifying the maximum allowable load on a branch circuit and the types of loads that are permitted. NEC Section 210.23 outlines the permissible loads for branch circuits, classifying loads as either continuous or non-continuous. It specifies the overcurrent protection requirements for each type of load. In the context of lighting circuits, NEC Section 210.70 addresses lighting outlets required in dwelling units, specifying the minimum number and location of lighting outlets in each room or area. It also includes requirements for lighting control and the use of energy-efficient lighting technologies. Now let's explore the practical implications of these NEC requirements. Firstly, it is crucial to accurately calculate the load on each lighting circuit. This involves determining the wattage of all lighting fixtures connected to the circuit and ensuring that the total load does not exceed the capacity of the circuit breaker or fuse. The NEC provides specific guidelines for calculating lighting loads, taking into account the type of lighting, the square footage of the area, and other factors. Secondly, it is essential to select the appropriate size circuit breaker or fuse for each lighting circuit. The overcurrent protection device should be sized to protect the circuit conductors from overheating and prevent damage to the connected loads. The NEC provides tables and formulas for determining the appropriate size of circuit breakers and fuses based on the ampacity of the circuit conductors and the type of load. Thirdly, it is important to ensure that all wiring methods and materials used in lighting circuits comply with the NEC requirements. This includes using the correct type and size of conductors properly in installing wiring devices and providing adequate support and protection for wiring. The NEC specifies the types of wiring methods permitted for different applications, as well as the requirements for grounding and bonding. Fourthly, it is crucial to follow proper installation practices when wiring lighting circuits. This includes making secure connections, avoiding sharp bends in conductors, and properly terminating wiring at devices and equipment. The NEC provides detailed instructions for installing wiring and equipment, ensuring safe and reliable electrical connections. Finally, it is essential to inspect and test lighting circuits after installation to verify that they are functioning properly and comply with the NEC requirements. This includes checking for proper voltage, current, and continuity, as well as ensuring that all devices and equipment are properly grounded. The NEC recommends conducting periodic inspections and testing of electrical systems to identify and address any potential safety hazards. Now let's consider some common scenarios involving residential lighting circuits. Imagine a homeowner is renovating their kitchen and wants to add new recessed lighting fixtures. Before starting the project, it is essential to assess the existing electrical system and determine whether it can handle the additional load. The homeowner should calculate the total wattage of the new lighting fixtures and compare it to the capacity of the existing lighting circuit. If the existing circuit is not adequate, a new dedicated circuit may be required. Another scenario involves a homeowner experiencing frequent tripping of a circuit breaker that supplies lighting and receptacles in a bedroom. This could indicate that the circuit is overloaded or that there is a fault in one of the connected devices. The homeowner should investigate the cause of the tripping and take corrective action, such as removing some of the loads from the circuit or replacing a faulty device. In another situation, a homeowner notices flickering lights in their living room. This could be caused by a loose connection, a faulty dimmer switch, or a problem with the electrical supply. The homeowner should troubleshoot the issue and take corrective action, such as tightening connections, replacing the dimmer switch, or contacting an electrician to inspect the electrical system. In each of these scenarios, it is important to prioritize safety and follow proper electrical practices. If the homeowner is not comfortable working with electricity, it is best to consult a qualified electrician to perform the necessary repairs or upgrades. In conclusion, residential lighting circuits are generally not considered continuous loads, but they should be wired as dedicated circuits in accordance with the NEC. This will help to prevent overloading, ensure proper circuit protection, and promote overall electrical safety. By following the NEC requirements and adhering to proper electrical practices, homeowners and electricians can create safe and reliable lighting systems in dwelling units. Additional considerations include the increasing use of LED lighting in residential applications. LED lighting is significantly more energy efficient than traditional incandescent or fluorescent lighting, which can reduce the overall load on lighting circuits. However, it is still important to calculate the total wattage of LED lighting fixtures and ensure that the circuit is properly sized. Furthermore, some LED lighting fixtures may have specific wiring requirements or compatibility issues with certain dimmer switches. It is essential to consult the manufacturer's instructions and follow proper installation practices when using LED lighting. Another trend in residential lighting is the growing popularity of smart home technology. Smart lighting systems allow homeowners to control their lighting remotely, automate lighting schedules, and integrate lighting with other smart home devices. These systems typically use wireless communication protocols such as Zigbee or Z-Wave to connect lighting fixtures to a central hub or controller. When installing smart lighting systems, it is important to ensure that the wiring and installation comply with the NEC requirements. The NEC provides specific guidelines for low-voltage lighting systems, including requirements for wiring methods, overcurrent protection, and grounding. It is also essential to follow the manufacturer's instructions and ensure that the smart lighting system is compatible with the existing electrical system. In addition to the NEC, there may be local electrical codes or regulations that apply to residential lighting installations. It is important to check with the local authorities to determine the specific requirements in your area. Local codes may have additional restrictions or requirements for wiring methods, overcurrent protection, or lighting control. They may also require permits or inspections for certain types of electrical work. By complying with both the NEC and local electrical codes, homeowners and electricians can ensure that their lighting installations are safe, compliant, and energy efficient. Furthermore, regular maintenance and inspections of residential lighting systems can help to identify and address potential safety hazards before they become serious problems. Homeowners should periodically check for loose connections, damaged wiring, and malfunctioning devices. They should also test ground fault circuit interrupter GFCI receptacles in bathrooms and kitchens to ensure that they are functioning properly. If any problems are detected, they should be repaired promptly by a qualified electrician. In summary, residential lighting circuits are an important part of the electrical system in dwelling units. By understanding the NEC requirements, following proper installation practices, and performing regular maintenance, homeowners and electricians can ensure that their lighting systems are safe, reliable, and energy efficient.